Planetary gatherings, the design blocks of our huge region, are at absolutely no point in the future as they used to be. A shocking 771 trillion close-by planet bunches have peculiarly evaporated, leaving the intelligent community befuddled. What follows is out-and-out staggering. From the profundities of space, new components have begun to surface, persuading us to reveal the truth behind the unexpected disappearing of 771 trillion planetary gatherings in our gigantic universe. Could there be a relationship between the vanishing of close-by planet gatherings and these secretive ghosts from the universe? Go along with us as we set out on a journey through the spreading out endless insider facts of vanishing stars. More than 771 trillion close-by planet bunches have vanished, and an upsetting eccentricity has emerged from the tremendous void. We will dive into the potential explanations behind the evaporating of planetary gatherings and look at the presence of this bewildering huge curiosity. Mankind has consumed millennia understanding ideas like science and number juggling, which assist us with getting a handle on our spot in the universe and the fundamental thought of Earth. Regardless of the way that the focus stays a secret, one vital idea is that matter doesn't just evaporate. It changes. Similarly, when a star explodes and disappears, its material scatters across the universe, continuing on in a different construction. This raises an intriguing mystery with regards to space: the vanishing of stars from our night sky. Immediately, this presumably will not show up particularly astonishing given the unlimited quality of the universe. Stars can vanish out of the blue for various reasons, like arriving at the completion of their life or getting moved into a colossal substance like a dark opening. At any rate, what makes the circumstance puzzling is that it's not 2 or 3 stars disappearing. There are countless stars, more than 700 trillion, that have unusually vanished, leaving cosmologists puzzled about how they might have glinted out of presence so out of the blue. While a couple of disappearing stars can be gotten a handle on in a universe as colossal as our own, the vanishing of a huge number, especially those that aren't moving toward the completion of their life cycles or sabotaged by outside powers, presents an absolutely extraordinary issue. Fortunately, a social event of committed specialists is excitedly endeavoring to unravel the mysteries of the universe. Volume 50 from the Nordic Foundation for Theoretical Physical Science in Sweden reveals insight into their undertakings, making sense of their endeavor known as VASCO. Their fundamental goal is to distinguish a star that has stayed a steady presence in the night sky as long as human memory and accessible records can review, only to startlingly vanish without a trace. Even the most progressive telescopes have failed to recognize any leftovers of such stars. This isn't simply an uncommon pursuit. The VASCO project has been dynamic since 2017 and has accumulated broad consideration. Each part is driven by their unique motivations to partake. The gathering perceives that certain pieces of the universe remain erratic in light of colossal distances, making it challenging to stock each brilliant article with absolute precision. Anyway, they keep up with their confidence in the ability of finding a specific sort of star all of a sudden vanishing from the night sky, a characteristic that has not been archived before. Is it truly workable for a star to evaporate without advance notice? The response is yes. For example, there was a star that space specialists immovably noticed for an extensive period spanning 20 years until 2019. This star attracted their advantage because of its astounding crystal blue splendor. Then, all of a sudden, it vanished from their insights. Andrew Allen, a doctoral understudy specializing in cosmology at Trinity School Dublin, critically examined and re-examined the information. The prevailing hypothesis suggested that the star had gone through a vast blast impact, changing into a dark opening. Anyway, there were no distinguishable signs of an infinite blast occasion or the normal outcome. Also, there was no recognizable dark opening. Considering the delay between perceptions, it appeared to be profoundly improbable that such a sensational occasion might have slipped through the cracks. This difference becomes evident when we compare it to our nearby cosmic region, the Virgo supercluster. The Virgo supercluster is smaller, about 110 million light-years in diameter, and is home to more than 2,000 galaxies, including our Milky Way. To give you an idea of the immense emptiness of the Boötes void, astronomer Greg Aldering once remarked that if our Milky Way were at the center of this void, we wouldn't have had significant awareness of other galaxies until the 1960s. In comparison, the Milky Way has about 24 neighboring galaxies in a region just 3 million light-years across. Considering the size of the Boötes void, it should theoretically contain around 10,000 galaxies based on the average distances between galaxies. Astonishingly, we've only identified about 60 galaxies within this colossal void, making them the loneliest galaxies in existence. The Hubble Space Telescope even captured an image of one of these galaxies, MCG plus 0102-015, a spinning galaxy residing in the Boötes void. The European Space Agency has described it as the loneliest of galaxies. How it ended up so isolated remains a mystery. In the image, you can see 3 stars in the foreground, all from our Milky Way. All the other points of light are distant background galaxies, resembling countless tiny organisms in a drop of water. How do these voids form? Simulations have shown that smaller, more typical voids result from the gravitational pull of galaxies drawing them together and leaving empty spaces behind. However, this explanation doesn't apply to the Boötes void, as there simply hasn't been enough time since the universe began for gravitational forces alone to clear out such an enormous space of this scale. Assuming the star had indeed advanced into a dark opening without any infinite blast activity, it would present a unique situation of vanishing without the usual dramatic show, a characteristic that has left space specialists searching for answers over an extended period. Bits of evidence pointing to such events date back to 2009, when a star that had gained attention from various telescopes appeared to be moving toward a peak. This star underwent a surprising transformation into a dark opening before researchers could fully comprehend the intricacies of the process. While significant proof remains elusive, this event left space specialists in a state of puzzlement. Similarly crucial is the collaborative effort of various research groups, including those mentioned earlier, in compiling extensive star catalogs and their characteristics. These catalogs enable cosmologists to access star data online and conduct broad comparisons. The findings have been both encouraging and stunning. As one researcher pointed out, they have identified various fleeting vagabonds that quickly appear in one image before evaporating, including many discoveries yet to be fully understood. However, there are still numerous anomalies that challenge straightforward classification. An assessment of some of these transient patterns ruled out possibilities like M-dwarf flares or nova events. Building on this, a prevailing idea among some space specialists is that the disappearing of these stars might be connected to the way light travels through the vast expanse of the universe. Imagine having a light source in your room and then leaving it until it vanishes. Now expand this scenario across galaxies. This raises the fundamental question of how we can see anything at all. The answer lies in the fact that the immense light beams sent by these stars take an extraordinarily long time to reach us. Even when they finally arrive, they blend with the beams from our sun, enhancing their visibility in our night sky. As a general rule, the light we see is often several billion years old. For instance, the light from our sun, which is relatively close, still takes about 8 minutes to reach Earth. When we apply this to stars located light-years away, the age of the light we observe becomes strikingly apparent. This seemingly abrupt vanishing of stars might be a consequence of the immense age of the light we see. Despite appearing sudden to us, the star may have ceased to exist long ago, and we are only now witnessing its absence. This also aligns with the concept of stars undergoing extended periods of brightness followed by dimming until they reach a point where they are no longer detectable. It's a perplexing notion, and while challenging, these questions must be raised to uncover the truth behind these anomalies. Some individuals are drawn to exploring Dyson spheres and other more extraordinary possibilities. Within these theories, for space specialists, one notable hypothesis concerning vanishing stars involves considering the role of extraterrestrial beings. You might wonder, how could extraterrestrial beings cause stars to disappear? The answer doesn't lie in making stars dissipate, but rather in the fascinating possibility that these massive celestial giants may be utilized for their purposes. Have you ever come across the concept of a Dyson sphere? While it currently resides in the realm of science fiction, it envisions a scenario where advanced extraterrestrial civilizations, or even rare phenomena on Earth, construct a colossal megastructure surrounding a star. This megastructure serves as a means to capture and harness the star's energy on a grand scale, effectively transforming the star into a titanic energy source or even a monumental instrument of power. This idea bears a resemblance to the scenario depicted in Star Wars: The Force Awakens, where the Star Destroyer base harnesses a star's energy to destroy several planets of the Republic. However, the practicality of such an explanation faces significant hurdles. At the outset, the existence of extraterrestrial life remains unverified. Furthermore, the realization of a fully functional Dyson sphere, even around a relatively modest star, would require an extensive amount of time and a level of technological sophistication far beyond our current capabilities. When we consider applying this concept across more than 700 trillion stars, it becomes an extraordinary cosmic endeavor with dubious feasibility. Despite this, the idea of the Great Nothing still maintains its proponents. So, where does this leave us? The answer is that we are left without definitive answers. What we do know is that something extraordinary is unfolding in the universe, prompting the disappearing of stars from our perceptions and view. This cannot be dismissed as an isolated incident. As we have seen, the undeniable absence of numerous stars raises the central question: what is causing such a vast number of stars to vanish within such a short span of time? This is precisely why individuals and organizations from diverse disciplines are focused on unraveling this mystery. Finding answers to these questions could provide us with a deeper understanding of the universe. If similar phenomena emerge in the future, we might be better prepared to decipher their causes quickly. While the mystery of disappearing stars continues to perplex us, something unique has recently emerged from the depths of the universe. Researchers have accidentally discovered massive voids in space that exceed our initial assumptions. These voids encompass scales that stretch from the solar system to the Milky Way. The universe is composed of such deficiencies, vast regions where celestial objects are remarkably sparse. Among these, one exceptional void stands out: the Boötes void, often referred to as the Great Nothing. When you gaze at the night sky, it often seems like there is a vast, evenly distributed region of stars. However, in specific areas like the Boötes void, things are entirely different. These regions contain very few celestial objects. Essentially, the universe has a striking structure: long filaments of dark matter threading through galaxies and clusters of galaxies, with enormous voids in between. The Boötes void has a diameter of approximately 330 million light-years, located near the Boötes constellation and about 700 million light-years from us. Initially, this void had only one galaxy. However, since its discovery, we have identified a few dozen more. The average gap between these galaxies is around 10 million light-years, which is several times greater than the distance between Earth and the Andromeda Galaxy. This leads us to the theory of cosmic evolution. When most people imagine the universe's expansion after the Big Bang, they likely picture galaxies spreading out uniformly, moving away from each other. However, a more complex pattern emerges when we examine the universe on its grandest scales. It's like trying to fit billions of light-years into a cube-sized computer screen. We should rewind the universe's clock back to its earliest moments, shortly after the Big Bang. At that time, the universe was an extremely compact region of intensely hot plasma. Despite being relatively uniform in density, there were slight variations or quantum fluctuations in spacetime. As the universe expanded, these small variations in matter density became more pronounced. Consequently, regions with higher and lower matter densities emerged.